Hello everyone, welcome to an algebra video tutorial. We are learning about simplifying expressions using exponent properties. So we've learned a lot of properties so far in this series. We've learned about the product property, multiplying, but we can add the exponents. We've learned about the quotient property. If we have division, we can subtract the exponents. We've learned about the power of a power property and how to apply that both to numbers, variables, and groups. And then we've learned about zero exponents, and we've learned about negative exponents and applying it to fractions and all sorts of good stuff. Well, over the next few videos, we are going to apply all of the properties into being able to simplify complicated expressions that have a lot of exponents in them. So here's an example we're going to do, but the steps we want to do to have a simplified expression means first thing we can have to do is no repeated variables. So when I look at this expression, I have an a variable there, an a variable there, I have a b there, and a b there. My final result when I simplify it, I should only have one a and one b. So that's the first step. I need to make sure there's no repeated variables. The second step, but the second thing to get to is I need to have no negative exponents. So I've got a -3 here, a to the -3rd. I have a b to the -3rd there. So when it's all said and done, when I'm finally simplified, there should be no negative exponents. And lastly, lowest terms. So if I have any fractions, I want to make sure they're simplified in the lowest terms, and exponents, all that good stuff. Everything's got to be in lowest terms. Okay, let's see if we can get those things to happen on this example here. I've got 2 times a to the -3rd times b squared. All of that is multiplied by 3 times a to the 4th times b to the -3rd, which is all to the 6th power. So I do have to follow somewhat my order of operations here. I can't multiply these yet until I deal with this fact that I've got an exponent of 6. So I'm going to apply the power of a power property, power of a power, and rewrite this 3a to the 4th, b to the -3rd to the 6th power. I'm going to rewrite all of that by giving everything inside the 6th power. And the power of a power property is I multiply the exponents. So it turns into 3 to the 6th. A to the 4th power, but I have 6 of them, means I end up with a to the 24th. 4 groups of 6, right? B to the -3rd taken to the 6th power. Power of property says multiply, so that turns into b to the -18th power. All right, we've just simplified all that using the power of a power property, but I still have all this in the front. 2 times a to the -3rd times b squared. There we go, step by step, and I just applied the power of a power property. All right, now I don't have any more exponents on the outside, so now I can open things up, and it's just one big multiplication problem. So I'm going to go ahead and write it all out in expanded form just for the sake of this example and to make things really clear. So we've got 2 times a to the -3rd, and I'm even going to write all of my variables in different colors. So we've got a to the -3rd times b, let's use this color for b, times b to the squared times 3 to the 6th times a to the 24th times b to the -18. I just color coded them because it'll help make sense of what needs to combine, and all this is one big multiplication problem, so it doesn't matter the order in which I do things. So I'm going to start with the real numbers. I'm going to start with 2 times 3 to the 6th. Well, 3 to the 6th, using my calculator, is 729. So that becomes 2 times 729, and that just equals 1,458. All right, let's now move on into my a variables, a to the negative third times a to the 24th. If I remember my product property, I'm going to write that on the side here. The product property says when you have the same base and you're multiplying them, so this is a to the negative third times a to the positive 24th, I can add the exponents together. So that turns into a with negative 3 plus 24, which ends up being a to the 21 power. So it turns into positive, which is kind of nice. All right, now let's look at the b's. I've got b squared times b to the negative 18th. Well, I'm going to use the product property again to write it as b to the second power plus the negative 18th power. And if I add those together, I get b to the negative 16th. Now I'm pretty close. I've got it down to where there are no repeated variables, right? Got a to the 21st power, there's only one a, there's only one b. I've got things in lowest terms, so there's no fractions to simplify. The only thing I still need to figure out is getting rid of all my negative exponents. I have this b to the negative 16th power. So I need to use my negative exponent property and realize that b to the negative 16th, well, that turns into 1, it's division by b to the positive 16th. So I can rewrite this whole thing then, if I had a fraction bar, this b to the negative 16th needs to come down on the bottom. So my final answer is I still have 1,458. My a to the 21st power is still on top, but now instead of multiplying by b to the negative 16th, it's dividing by b to the positive 16th power. And there we go. We have just simplified this expression into that. That is the equivalent expression, but it's simplified. There's no repeated variables. There's no negative exponents. It's in lowest terms. I'm feeling pretty good about all that. Hopefully this is a helpful example for you to see using multiple properties of exponents all used together to simplify and get to a much nicer expression.